1958 AWA 209C console television, which I'm restoring at the moment. But one of the interesting things is every single resistor in this tuner has gone high. One of them's even completely open circuit. Found completely open circuit resistor which was here in the AGC. It was open circuit one, yeah, 470k. So yeah, the IRC resistors, which were used in most Australian televisions now in the year of 2024, you've got to check every single one of them. Even some of the low value ones have gone high. So it's not like it was, you know, 40 odd years ago when I got into this. You'd only have to change a few paper caps and that'd be it. So question is, what does the set look like? Well, I've got it in the other room. Yeah, this is the back of the set I've taken the chassis out of. The picture tube is a 17 BJP4, and you'll notice it's a short straight gun tube. This is just after the ion traps had gone out of fashion. Some of the earlier versions of this set do have the 17 AVP4, which is the bent gun ion trap job. And I've got another set over here, which is the same thing. I mean, this set I've got to go through and do as well. But that's what the front of a 209C looks like. And we'll just have a quick look at the circuit and service manual, and I'll just tell you a bit about the set itself. Alright, the 209C belongs to a series of, how can I say, base model AWA sets. They were the first of the 90 degree sets, released in 58, and they were, yeah, a no frills version set. If you know, wanted a television and didn't want to pay too much, well, that's what you got. So there's the 207C, the 209C, which is what I'm doing, the 211T and the 212C. Both those are the 17 inch and those are the 21 inches. The chassis is the same for all of them. So yeah, 17 valves, and they have some interesting shortcuts. I'm just going through the manual here. Okay, so they've cut down on the number of valves. One of the ways to do that, instead of a triode pentode in the upmarket model, which is a 6AV6 and 6AQ5, they've just got a single 6BV7 here. And I think the upmarket model's got an extra sound IF. One of the cost-cutting features is the simple, well, it's not simple, but it's a simplified peak level AGC. It's not gated. So an interesting feature is they're using the 6U8 detector triode as two diodes, one as the detector for the video amp, and the other as the peak level detector for the AGC circuit. The video amplifier is AC coupled, so no true black level. What else? Yeah, going back to the tuner, yeah, every resistor in this tuner I've got to replace. The thing is a prick to work on because yeah, you've got to desolder all these shields to get down into the guts of it, and you can see, I don't know if I can focus on that, but you might be able to see one of the replacement resistors I've stuck in there. But I've done the RF amplifier, the 6BQ7, and now I've got to go through and do the 6U8 frequency converter, so then I can put it all back together. Another thing, oh, this tuner is actually It's an RCA design which AWA have made locally, you know, with our channels and, you know, locally sourced components, but it is based on the RCA incremental tuner from the 50s. One of the things that happens with them is the tuning shaft seizes up, so you've got to take all of that apart and lubricate, and then it's all happy. But otherwise, it's, you know, they're a nice set to work on because there's no unnecessary or complicated features. It's like a textbook television set. And I'll just, before I stop the video at this point, we'll just have a quick look at the other side. Notice the 6U8 here. Someone has changed the socket to put a shielded socket in its place, which I've got. But it's a curious thing why the socket has been replaced, and also the 6SN7 line oscillator AFC valve socket has been replaced as well, which is odd. It's had some odd things done to it, and I mean, some of the parts I've taken out of it, which the previous owner put in it, I mean, there's like, this is a 2 meg resistor out of a 1940s radio. There's even a body and dot resistor which had been put in the frame output circuit. Yeah, so the few strange things that had been done. Some of the resistors that he'd put in it have already gone high, but you know, they are all IRC. So I'll continue on with that. I mean, there's no point in watching me change resistors in a tuner. I think that would be quite boring, so I'll get on to all of that, and I'll come back to the video once I've got a bit more done to it. Now, I was talking about the upmarket models of this chassis, and here it is, the 204T, 205C and 206C, and they've got 24 valves, and we'll just have a quick look at the extra things they've got in the circuit. Now, if I can open up the manual here. Okay, one of the points of note is 25AS4 rectifiers instead of one. The video stage is mostly DC coupled. It's got gated AGC. The sync separator is more complex, so it's got more wave shaping components in it. And yes, I was right about the 2 sound IFs. So it's got extra gain. Oh, and yeah, it's got 4 stages of video IF rather than 3. The tuner is the same. The line oscillator output is the same as the cheaper chassis. The frame oscillator or vertical oscillator output is the same. So yeah, it's mainly, it's a higher gain set, RF, IF wise, and the audio is more complex. It's actually got feedback, proper tone control, and yeah, DC coupled for the video amplifier. And it just so happens I have a 206C here, which is the 21-inch job. I like the fancy doors, but yeah, it's got the same physical chassis, but with all the valve positions occupied. I haven't done this setup yet, But yeah, that's to come in a future project. I'm up to the converter stage of the tuner. I've had to take the whole coil assembly out. So for those of you who haven't seen a close-up of an incremental tuner, this is one of the coil gangs in it. So the rotary switch selects one of the coils. All the coils are in series with each other, and as the wiper of the switch goes around, it just selects the appropriate amount of inductance. So the question is, how well is the tuner going to be in alignment when I put it all back together? Because I've disturbed things, but we shall see. So there's all these resistors down the bottom there which I've got to change. They're all high, so that's where we're at the moment. The tuner is back together. I've replaced all but 3 resistors in it. The resistors I haven't replaced, one was close enough to be in tolerance and is not in a critical position. Another one is an AGC feed resistor, which again is not critical, and there's a 120 ohm resistor across the converter valve heater, which was 120 ohms and is now 140. I'm not sure what the purpose of it is, but it's not critical. Anyway, I hope I have reconnected everything, because it's all back together. The fine tuning, just for those who are interested, it's a piston trimmer. You can see the back of the capacitor in there maybe. So that's ready to go. I'll just put the covers back on, and we'll have a look at the resistors. Alright, let's check some resistors. Okay, we'll start with the 1 megs. 1.67 meg, so it's well out of tolerance. Yeah, this one's completely open circuit. They were in the RF amplifier. We'll go down to the 100Ks. So that's 140K instead of 100K. $152K instead of 100K. $128K instead of 100K. Now we'll get down to the lower values. The 15K, which is the damping resistor across the output transformer. 20K instead of 15K. And 2.54K instead of 2.2. Yeah, look, it's close enough. I probably could have left it, but it was an easy resistor to change. And 1K resistor. It's 1.46K. Another 1K, which is now 2.52K. And finally a 120 ohm cathode bias resistor for the RF amp is 150 ohms instead of 120. So that's why IRC resistors are a problem, and when you're restoring your vintage radio and TV, yeah, these are just as bad as paper capacitors. So yeah, that's what they look like, if I can get it to focus. But yeah, right, this is the valve which is unshielded because someone's changed the socket to a plain type. I'm not too keen on that because the 6U8 is not internally shielded. So I'm going to do the correct thing, and I have this shielded socket to put in its place. I've put the shielded socket in, so I'll put in the 6U8 and put the shield on top. God, that's tight. Okay, in, done. The one last component replacement I'm going to do is this rubber wiring. Most of the set is in solid core PVC wiring, which is in good condition, but this rubber stuff, it's gone very hard, and although it hasn't crumbled, what I'm worried about is there's a green corrosion which is coming from the rubber, and although it's not going to actually cause any problems, I'm just worried that it might get into the windings of the transformer. We don't want that, so I've got to replace all the hard rubber wires there. Fortunately they're just down here. Yeah, you can't quite see it down there, but there's something in the rubber which is sort of leached out and attacked the cadmium plating on the chassis. So I don't know if it's some kind of acid or something. Alright, so that's the final component replacement, and then I'm going to reform the electrolytic condensers with the current limited supply, because now they're old enough where you should worry about doing that. You know, 40 years ago when I started working on these chassis, you could just plug it in and it's all good, but now they're old enough that you should reform them so they don't go bang and cause unhappiness. And this is the 2-valve regenerative, or super regenerative, FM receiver that keeps me company while I work. Mallory 245 vibrator, 6Y9, and inside the box is a 6B8. And this is 2NUR, playing good quality music from 135 kilometres away at Newcastle. Okay, I've got the rubber wiring out, and it's all new PVC, nice and soft, unlike this. You have to look at very, very solid. Yeah, there's no flexibility in that at all. So it's good that that's out, so we won't get any corrosion. Next thing is to reform the electrolytic capacitors. So I'll put current limited DC onto the B+ line and see what happens. Okay, now I'm going to attempt to reform the electrolytic capacitors on the high tension line. So the capacitors are here, they're the first and second filters. There's several decoupling capacitors here. The audio output's got one, and the vertical output's got another one. So all I'm doing is connecting this DC power supply, variable up to 400 volts, but I won't go that high obviously, through a 15 watt 240 volt light bulb, which will limit the current to 60 milliamps, and then that goes into the high tension line at the fuse. So it will turn on, and I've also got a voltmeter here so we can actually see how the voltage rises as the capacitors reform. They might be 100%, we don't know. So we'll turn on and see what happens. So that's 100 volts. And notice how the bulb dims as I increase the voltage. So that means the capacitors are reforming. So the idea is to keep the current flowing until the voltages come up and stays there. That way we know that the leakage current in the capacitors is at the minimum. So we'll go up to, we're up to 250 at the power supply, and we're measuring 220 thereabouts on the high tension line, so there's still a little bit of leakage, but that will decrease over a period of probably a few minutes with this. So once I've done this, the chassis is ready to go back in the set. The chassis is back in, but no joy. No EHT. The 1B3 looks like it's not under vacuum. Nice blue glow there. Well, there's a very weak dim raster with another 1B3, so I'm thinking there's still a problem with the line output stage, so I'll try the 6DQ6 next. Alright, where I am with it now, I've been using the B&K 1076 television analyst to substitute for the line output. It made a little bit of difference, not a heap. I've got a replacement yoke which I just plugged in, and I found that the boost voltage went up to about 585. It's about 400 with the original yoke, so I'm just trying to get the yoke off, and it's stuck on the neck of the tube, and the base of the tube is a bit loose, so we don't want to pull that off. So let's see what happens when I change this over. As with all these jobs, there's always a catch. This time I can't get the yoke over the tube base, and the tube base is loose, so I'm going to have to desolder the tube base. Okay, tube base off. Now can we get the yoke off? Alright. Doesn't look burnt, but anyway. Well, it's a lot happier with that yoke. So that's a big improvement. Okay, I've got another yoke in it. It's all happy. Yeah, the 6DQ6 that was in it was also weak as well. The getter has gone a bit milky in it, so I presume it's sort of got a bit of air in it, which is why it's crook. Also discovered the 6CB6 first IF amp is inoperative, and that looks like it's gone to air as well. So it's all working through the tuner and everything. Replacement yoke in there. I have to do a bit of tidying up. It's almost done. I have to take the tube out and clean the glass. There's some mould in there. Also, the vertical hold is right at its limit, so there's a couple of resistors that need checking again. But otherwise it's looking pretty good. I've just taken the tube out, ready to clean the glass. It looks like the tube's been taken out before at some point.
She was quite trendy at the time.
Okay, that's where we're at the moment. Slight problem with the vertical output, a bit of bottom cramping there. If I try and stretch that out with the linearity control, the top cramps up, so a common cause of this problem is the electrolytic bypass on the 60Q5, so I'll check that. There's a little bit of intercarrier sound buzz when there's peak whites, so hoping just tuning the ratio detector coil will fix that. Yes, I'll try those two things next, but we're getting very close to the end of this restoration. Well, it's looking pretty good now. There were a few more resistors that needed replacing, which I'd missed before, so I'm quite happy with the picture geometry at the moment. Those of you who notice detail might notice a slight increase in brightness at the top of the picture compared to the bottom, and that's happens to be a characteristic of the AC coupled video system, so it's just part of the design. I've tweaked up the sound IF, that's the ratio detector transformer there, which has helped a bit with the intercarrier buzz. So the remaining thing really is to just go through the local oscillator settings on each of the channels and see that they're happy. Then I'll put the legs back on the cabinet. At the moment I'm gluing the veneer back down, which is why the book and the transformer's on the top. So just about there.
All cars come with a 5-year warranty and roadside assistance. Don't miss the genuine savings. Visit Ozcar at 229 Hume Highway, Lansvale.
It's working pretty well now. One of the things I have tested is the vertical blanking capacitor here to get rid of the retrace lines. I needed to add about another 0.05 to it, so that's about 0.12 microfarad capacitor which I need to put in that position, and I've just been using a decade box to test that. And here are my other workshop sets.
But 1,000 years before the first Golden Temple was built, people in ancient India were already scheming and plotting their next move, playing chess. Back then, the game was played with a roll of the dice.